Today we are learning about solving quadratic equations by using the quadratic formula. I know I've got this when I can use the quadratic formula to solve quadratic equations, approximate solutions to quadratic equations, and determine the number of solutions of a quadratic equation by using the discriminant. So we have some new vocabulary this time. Standard form is when you write all the terms in order from the highest exponent to the lowest on your variables. Quadratic formula, I'll show you that in a second, and then the discriminant. So another technique for solving quadratic equations is to use the quadratic formula. The formula is actually derived from completing the square of a general quadratic equation. You need to pause this and write down this formula. This is a quadratic equation. You are going to be responsible for knowing it. So x equals negative b plus or minus b, the square root of b squared minus 4ac all over 2a. So these are the steps. Write the quadratic equation in standard form. That's number one. If necessary, clear the equation of fractions to simplify your calculations. You can, you don't have to, it's up to you. Identify a, b, and c, and then replace a, b, and c in the quadratic formula with the identified values and simplify. So number one, solve 4x squared plus 2x minus 2 equals 0 using the quadratic formula. So they already have given you the equation in standard form. So our a is going to be 4, our b is going to be the 1 because it's assumed to be right there, and our c is this negative 2. So I'm going to use all those in this quadratic formula. Okay, so I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you see, all I'm doing is I'm replacing the variables with the values from the problem. Okay, now I just simplify. So I have negative 1 plus or minus. Remember, order of operations is very important here. So 1 squared is 1 squared comes first because it's exponents. Now all this is being multiplied together. So negative 4 times negative 4 is negative 16 times 2 is positive 32 over 8. So that's going to be negative 1 plus or minus the square root of 33 all over 8, and that cannot be simplified. So that is your final answer. Okay. So 1b, same thing, it's already in standard form. Okay, so our a is 11, our b is the negative 9, and the c is that negative 1. So I'm getting these right here. Right? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I'm going to fill those in. X equals negative b. Now, since b is already negative, you make it positive. B squared minus 4ac all over 2a. So order of operations, so I've got 9 plus or minus the square root of 81. Negative 4 times 11 is negative 44 times 1 is a positive 44. And then 2 times 11 is 22. So I can simplify those, combine like terms, you get 125. And then 125 actually can be broken down into the square root of 25 times the square root of 5. So then that can be rewritten as 9 plus or minus 5 square root of 5 over 22. Okay, now I'm going to let you try one. Well, nope, I'm still doing one. Never mind. Okay. Do more. All right, so get this in standard form, which means that I need to set one side of the equation equal to 0. But look what happens. Okay, so A is 8. I don't have just a plain X. So my B is actually 0 and my C is -3. So I'm going to go negative B plus or minus the square root of B squared minus 4AC all over 2A. So when I do that, I simplify. I don't need that 0. So I have plus or minus the square root of 0. Okay, so I don't really need that. -4 times 8 is -32 times 3 is 96. And then that is over 16. 96 actually can be broken down into 16 times 6. And then we know the square root of 16 is 4. And now I can simplify my outside numbers, right? So that can become, my final answer is now going to become positive or negative square root of 6 over 4. So when there's a value missing, like the X was missing and that its coefficient would be 0. All right, so here's another one that I can do with you. Now, we can do it just by saying A equals 1/8, B equals 1, and C equals -5/2. Or we can clear out the fractions using multiplying by the least common denominator, which in this case would be 8. So if I did that, I would get x squared plus 8x, and then that would be -20 equals 0. And then it becomes a lot easier, okay? So we have x equals, oh, I'm sorry, my A is 1, my B would be 8, and my C is -20. So now if I do all that, I would get negative B plus or minus the square root of B squared minus 4AC all over 2A. So if I combine like terms, let's do under the radical. 8 squared is 64. -4 times a -20 is a positive 80. And now if I add, let me erase this a little bit, give us some more room. Okay. Now if I combine those, I would get the square root of 144, which we know is 12. So if I said -8 plus 12, I would get 4 over 2, which is 2. And if I did -8 minus 12, I would get -20 over 2, which is -10. So pause it here and you try some. Okay, the answers are off to the side. Look at what you see on I. It says no real solutions. That would mean that there is a negative under the radical. All right, so let's talk about the discriminant. The expression under the radical sign in the formula b squared minus 4ac is called the discriminant. So the radicand in the quadratic formula is called the discriminant. The discriminant will take on the value that is positive, 0, or negative. The value of the discriminant indicates two distinct real solutions, one real solution, or no real solutions, respectively. So here you can say, if you have a positive discriminant, you're going to have two answers, two real solutions. If it's 0, you have one real solution. If it's negative, you have no real solutions. Okay, so let's try this. So if we have positive, we have 1. I'm sorry, if we have 2. If it's 0, we have 1. And if it's negative, we have none. So that's how this works. Okay, use the discriminant, which is b squared minus 4ac. to determine the number of solutions. Okay, so in this, our A is 1, our B is -7, and our C is 6. So I'm going to say B squared minus 4AC. So that would give me 49 minus 24, which is 25. So the value of the discriminant is positive, which means I have 2 real solutions. Okay, same thing for this one. The difference is you have to put it in standard form first, okay? So we would need to write it 12x squared minus 4x plus 5 equals 0 before I get started. So I would have b squared minus 4ac. So when I do this, 4 squared is 16, and then -4 times 12 is, I'm sorry, -48. And then I've got that times 5. So when I do that, I would get 16 minus 240, which is -224. So since it's negative, there are no real solutions. So when your discriminant is negative, you have no solutions. That's because underneath the radical, you would have a negative number, and you can't do that. Okay, so you go ahead and try this one. Pause the video. And your discriminant should have been 0, so you would have gotten that there was 1 real solution. All right, here's some extra practice for you. Go ahead and try to, you're going to use the discriminant to determine the number of solutions. And those should have been your answers. Okay, so I know I've got this one. I can use the quadratic formula to solve quadratic equations, approximate solutions of quadratic equations, and determine the number of solutions of a quadratic equation using the discriminant. Do you really understand? So what is the quadratic formula used to find? It's used to find the solutions of quadratic equations that are also the x-intercepts of the equation when graphed. So remember, all these different ways that we've been learning to solve quadratic formulas: factoring, completing the squares, quadratic formulas, square root property, all of those things are used to find the x-intercepts of the equation when graphed. How does the discriminant help you determine the number of real solutions? Since it's the radicand, it determines whether its values are going to be positive, which would mean you would have 2, 0 if it's 1, and negative, you would have no solution.